So during this break, I decided to get my science and math on by doing some programming on a project. Uh, the project is inspired by something that I did at UVA when I was working there, and we were trying to find a way to keep people in a certain state of consciousness so people can go into what's called delta, beta, alpha. There are states of consciousness where your brain waves are at certain frequencies. And so we had written, or I had written, a program for UVA that took data coming in from an EEG machine. So it's coming in as basically wave forms and changing that into something that we could make musical sounds with. So as long as people stayed in a certain state, they heard this nice musical sound. If they went out of that state, then they lost the sound. So it was a kind of a way of being able to meditate and stay in a certain state of consciousness using sound waves and brain waves. So my idea was to take my little Raspberry Pi here, and I wanted to basically be able to take singing or voice or whistling and convert it into musical notes. And that might sound funny, but I basically wanted my voice to be translated into some kind of synthesized sound. So I wrote a program in Python, and the mathematical part of it uses something called a fast Fourier transform. And basically what it does is when a microphone, which is this little guy right there is a microphone, that's a Midi cable connected up to Janet's keyboard, and underneath there's a network adapter. So this is actually connected up to our home network. But anyway, the idea is that when sound goes through a microphone, it's digitally transformed into pulses. And you want to take those pulses and turn them into frequencies. Well, that's what a fast Fourier transform algorithm is really good at, is taking a very strange waveform and running it through the FFT, and it will turn it into frequencies. I also wanted to be able to control the volume of what was being sent, and so I used another mathematical algorithm called a root mean square. So basically what I'm doing is I'm sampling the microphone, and the samples are being caught in this Python program in a buffer, and as this buffer is accumulating data, I am running the fast Fourier transform, and I'm running the root mean square on whatever's in the buffer for a period of time. And then I get frequencies, and the frequencies I can then match up to MIDI notes or notes on a keyboard. You know, A on a keyboard, like A on a keyboard, has a frequency of 440 hertz. So I can match up what's coming in or coming out of the fast Fourier transform with MIDI notes, and so I can then send those notes when I get them from the Raspberry Pi after it's done its calculations to the keyboard through the Midi interface. And if it works well, you should hear my voice or whatever converted into sound. So I'm going to run the program here, and I've got it using what's called a program patch of 47, which is this kind of synthesized sound. And so it's going to be kind of hard to record this because you're going to hear my voice, but hopefully hear the sound coming out of the keyboard at the same time. I'll try to keep the camera pointed up while I make some noises through the microphone so you can hear. Okay, we're going to try doing this so you can hear. So if you can see on the screen, I've actually got it writing out what the MIDI note is, what the actual note is, how long this is, and volume. And the voice on the very end is the patch that I'm sending, which is the synthesizer. So I can start it up with any number. If I wanted my voice to be a piano, it actually sounds kind of strange, but I'll post it up. I'll break this and start it. A piano patch is usually number 1. And so now I'm starting this piano patch, and I'll do the same thing with the microphone. And so it's playing a piano sound, and you can do that with saxophone or flute or kind of whatever you want. It's an interesting process here. So that's about it. You can see as I'm talking, the notes are changing because the microphone's picking it up. A more sensitive mic would be better, but this is a first attempt at everything. So that is Frank Applin getting his science and math on during the coronavirus break.